Analog signal modules are also divided into two categories: analog input signal modules and analog output signal modules. In order to better understand how these modules work, we're going to continue our discussion with a practical example. Okay, suppose that we want to control the temperature of an industrial furnace by a PLC, meaning that we want to keep the temperature of this furnace within a certain range, such that the temperature won't get either lower or higher than that range. The first step to control the furnace's temperature is having a facility that measures the furnace's temperature for us, which tells us the furnace's temperature at any point in time. In order to measure the furnace's temperature, we can use a thermocouple. A thermocouple is a type of heat sensor that can measure the temperature for us in a certain range. For instance, we assume that the temperature range of the thermocouple that we have here is from 0 to 1800 degrees Fahrenheit, meaning that it can measure the temperature of the furnace for us between 0 and 1800 degrees Fahrenheit. So after the thermocouple measures the furnace's temperature for us, it has to transfer this measured temperature to the PLC through a signal. Now, what kind of PLC module can receive this signal from the thermocouple? A digital input module or an analog input module? In this case, we need to use an analog input module. Now, the question here is, why do we need to use this module? Can we not use the digital input module that we used to use before in here as well? The answer is negative. Why? Because the signal that is received from the thermocouple is not a digital signal, or so to speak, a 0-1 signal, but it's a signal which is in a certain range, and in this specific range, meaning 0 to 1800, it can have any value. For example, the value of this signal could be 100, 500, 1200, or any other value between 0 and 1800. Hence, we can't connect this type of signal to a digital input module, which can only receive 0 or 1. Therefore, we need to connect that to an analog module that can potentially receive an analog signal from a thermocouple. In fact, in industry, due to the fact that the receiving signals from a thermocouple could be very vulnerable to the noise that is generally present in an industrial ambiance, and the calibration of the thermocouples and wiring them to the analog input modules has its own problems, usually they convert the thermocouple signal to a 4 to 20 milliamps standard signal, which is also an analog signal, by means of a signal converter, and then they connect it to an analog input module. So we've placed a thermocouple to measure the furnace's temperature here, and we've connected it to the PLC analog input module. Now, just like before, this analog input module converts the received signals to the data that can be processed, and it sends it over to the CPU. The CPU then processes the data we've given to it as usual, and sends the result to the output module. So now, should the output module be a digital type or an analog one? In order to determine the type of the output module, we first need to see what type of actuator we need to connect from the output, and then based on the signal that this actuator receives, we can determine whether we need to use a digital or an analog module. In order to warm up an industrial furnace, they usually use a burner. These burners are typically gas burners, meaning that they work with gas. The amount of heat that these burners create is directly proportional to the incoming amount of gas to the burner. The more the incoming gas to the burner, the more gas it burns, and hence, the more heat it generates. And the more limited the incoming gas to the burner, the less heat the burner will generate. So, in order to control the heat generated by the burner, and therefore the amount of heat of the furnace, we need to somehow control the amount of the incoming gas to the burner. In order to do so, we can use a special valve called proportional valve. The way this valve works is it gets in the way of the incoming gas to the burner, and in this case, the amount the valve opens up will control the amount of the incoming gas to the burner. The more open the valve, the more gas passes through and gets to the burner, and therefore the more heat the burner can generate by burning the gas, and the more the valve is closed, the less the amount of gas passes through, and hence the burner generates less heat. Proportional valves usually receive a 4 to 20 milliamp signal at the input. The amount by which the valve opens up in these kinds of valves is directly proportional to the electric current that they receive. The more the applied electric current, the more the valve opens up. For example, if the amount of current that's applied to the valve is at the minimum, which is 4 milliamps, the valve completely closes. If the incoming current is 12 milliamps, the valve is half open, and if the current gets to its maximum amount at 20 milliamps, the valve opens up completely. Therefore, the amount of current that applies to the valve is somewhere between 4 to 20 milliamps, and based on this, the valve opens up more or closes down more. In here, the difference between the proportional valve and solenoid valve, which we learned about in the previous lesson, also becomes clear. In the solenoid valve, the valve had no more than two statuses. It was either completely closed or completely open. However, in proportional valves, the amount by which the valve is open or closed depends on the amount of current that is applied to it. For example, this means that in here, the valve could be 10%, 30%, 70%, or 100% open. Okay, so the signal that the valve receives is an analog signal between 4 to 20 milliamps. Hence, we need to connect it to an analog output module. Doing so, after measuring the temperature of the furnace with a thermocouple, the CPU processes this value based on the program that's been given to it, and then it sends the necessary commands in terms of 0 and 1 data to the analog output module. This module also converts this data to a 4 to 20 milliamp signal and sends it to the valve. Therefore, if the measured temperature by the thermocouple is less than the temperature that we want, the output module orders the valve to open up more so more gas gets into the burner, and so the burner can generate more heat. However, if the measured temperature is more than our desired temperature, the output module orders the valve to restrict the passage of the gas in order to decrease the temperature of the furnace. So, in here, both the analog input and output modules act as a connector between the sensors and the actuator and the CPU. The input module is a connector between the thermocouple and the CPU, and the output module is a connector between the CPU and the valve.